Okay, so we are given a shape on the board, and we are told that a triangle ABC is inscribed in a semicircle, and we have to find the area of this triangle ABC, given that O is the center of the circle. So now, how do we actually solve a question like this? So we just have to pay attention to the diagram above. Now, if you look at the diagram, you can see that OB is a radius of the circle. Why? A radius of a circle is a line drawn from the center of the circle to any point on the circumference. So you can see line OB is drawn from the center to the circumference of the circle. So this gives us a radius of the circle. Likewise, line OC is also a radius. You can see drawn from here to this point, and line OA is also a radius. So we have 3 radii in this diagram. Now, what can we see again? Now, we have a semicircle. Now, there's a theorem that says that the angle in a semicircle is usually a right angle triangle. So what does it mean? It means that the angle sustained by this triangle ABC is a right angle triangle. So angle ABC is equals to 90 degrees. That's a theorem. Angles in a semicircle is a right angle triangle. So we can put our sign here or symbol for angle 90 here. So now we have gotten some useful parameters for this question. Now, what are we going to do next? Now, if you look at this triangle OBC, it's an isosceles triangle because it has 2 sides, OB and OC, to be equal. So we can calculate the other angles here of this triangle. How do we do that? The angles can be getting by what? 180 minus 60. Now, since the angles are equal, we divide by 2. So which is what? 120 divided by 2. So the angles we have what is 60 degrees each. So here is 60 and here is 60 degrees. Now, what can you say about the triangle OBC? It has all angles equal. Thereby, triangle OBC is what? An equilateral triangle, because all the angles are equal, so all the sides will be equal. Now, we have what? The angle 90. We have gotten some angles here. Remember, the question is to find the area of the triangle ABC. So we need another parameter. Can we calculate the length of this line AC? That's the diameter of the circle. Now, AC is the diameter of the circle because it is a semicircle. So the line that divides a circle into 2 equal halves, for you to get a semicircle, is a diameter. So line AC is a diameter. Now, how can we calculate this? So not to confuse ourselves, we can bring out the triangle out like this. This is the triangle, something like this. Now you have what? Angle 90 here. Let's focus on angle 90. You have your 6 here, and we want to calculate AC, and you have your angle here 60. Now, how do we calculate it? Now, we know that from SOHCAHTOA, this is the opposite, the angle facing. I want to use this angle to calculate the line AC. So the angle facing here is the opposite. Then where the angle lies with angle 90 is your adjacent. So here, the longest side of the triangle is your hypotenuse. Let's call it H. Is that okay? So now, how can I calculate H, which is the same thing as what? Line AC. Now you can see that when I do this, what will I have? What? Opposite over hypotenuse, that is sine 60 degrees is equals to what? I'm using SOHCAHTOA. Opposite 6 all over hypotenuse, which is our H. Then if I make H the subject of formula, what do? I cross multiply. So I have H times sine 60 is equals to what? 6. Then I divide both sides by sine 60. Divide through by sine 60. Then I cancel out. So my H is equals to what? 6 over sine 60. Now, my H is equals to 6 divided by sine 60 in short form is given by what? root 3 over 2. So my h is equals to what? 6 times, now since I'm multiplying, I can invert the fraction, 2 over root 3. So you can say my h is equals to what? 12 over root 3. That means my diameter, line AC, so therefore line AC is equals to what? 12 over root 3. So I've gotten my distance here, 12 over root 3. Now how can I calculate the area of this triangle? Now there's a formula for it. Since I have an angle, the formula for the area of a triangle can be given by what? Half B, or the length AB sine C. Now what is AB? AB represents the length and C represents the angle between them. The angle must be between them. So now I have a length given here as 6. So this can be my A. I have another length now which is calculated as what? My 12 over root 3, which can be my B. So what will be my C? My C now will be the angle between here. So I have to calculate this angle. Let me call it X degree. Do you see that? I have to calculate this angle. So how do I do that now? From the diagram, you can see that all here is 90, but here alone is 60. It means here will be what? 90 minus 60, 30 degree. Now, also remember that the triangle OBA or OAB is also an isosceles triangle. So what does it mean? It means that the bases are equal, the base angles are equal, so that my x now is equals to what? 30 degree. Now I've gotten my value. So now I can now get my what? Area of this triangle. It becomes what? Half times A, take it as 6, times B, my B is what? 12 root 3 over root 3, times what? Sine what? The angle between them, sine 30 degree. So which gives me what? Half times 6 times 12 over root 3 times what? Sine 30 is what? Half also. So I can do my division. 2 can go here, 1, 2 can go here, 3, 2 can go here, 1, 2 can go here, what? 6 times. So 6 times 3, so my area becomes what? 18 over root 3. 6 times 3, 18 divided by root 3. I can now rationalize times, now if you are dividing by a sword, you can rationalize times root 3 all over root 3. So my area becomes what? 18 root 3. That's 18 times root 3 all over. Now if two equal swords are multiplying each other, what will happen? The square root sign will cancel out. We have 3. So 3 can go here 1, 3 can go here what? 6. So my area becomes what? 6 root 3. You can put it as what? Square unit.